Hello, thank you for joining us at the Data Phantom and welcome to this video. Today we'll be talking about data quality, what it actually is, why it's so important and how it can help you. So without further ado, let's get into it. This is a video about data quality, but it's probably worthwhile just looking at the word quality itself before we dive into the data bit. So what comes to mind when you hear that word? To you it might mean exotic food or dusty unpronounceable wine, expensive jewellery or the most inappropriate sports car. I wouldn't disagree with that, they all sound pretty good. But it is a strange word though. We all have a view of what it means, but it can mean different things to different people. Maybe there's a slight misunderstanding of what the word actually means, so first we'll cover that. The definition you can see might differ slightly from what you were expecting. The characteristics of a product or service that bear on its ability to satisfy stated or implied needs. It's the last bit especially that's so surprising. The ability to satisfy stated or implied needs. Therefore, what this means is that quality doesn't necessarily imply expensive, rare, exclusive or high-end. It just means something that's good enough for the job in hand. We'd probably all agree that this weird eggy looking salad thing would be a quality option. But what about looking at it through a different lens? We need to shift our mindset to view quality as something that depends on your need. For example, if I'm looking to get some food to impress someone, this egg surprise would indeed be a quality option. In other words, it has the ability to satisfy my stated or implied need. But if my need is purely to satisfy my hunger and smash some calories down, the dirty pizza you can see is high quality too. In fact, it's maybe even better than the egg thing, which doesn't look particularly filling. The pizza does the job I need it to do and is therefore quality. It's really the same with data quality. When we talk about something having good data quality, it doesn't necessarily mean that it's perfect. It means that it's good enough to do the job. To illustrate this point even further, we're going to use a simple example of an online bank statement. You can see lots of data on there, the customer's name, their account number, their balances and their transactions. Our customer's been to the petrol station, the supermarket, a restaurant, and she's been paid her salary. This will help us do two things. Firstly, we'll use it to highlight what we call the 11 dimensions of data quality, with a dimension being a measurable characteristic of data. This will become clearer as we work through the examples. You may read elsewhere that there are 6 dimensions, 7, 9, or the 11 that we'll show here. Certainly some are considered more important than others, but in this video we want it to be as comprehensive as possible. The second thing we'll look at is how assessing those dimensions allows you to start defining rules to make sure your data is good enough for the job in hand. The first dimension is accuracy. In other words, the degree to which the data reflects the truth. What kind of issues would this present to the customer if the data wasn't accurate? Well, for example, if the statement says that a customer went to the petrol station and spent £50, but they didn't, it would mean that the data on the statement was not accurate. What kind of rule could the accuracy dimension help drive then? In this case, a rule could be that the data displayed must reflect exactly the transactions and figures that are held in the bank's databases. Secondly, then we move on to completeness. In other words, is all the data that you need to be there actually there? If you have any gaps in your data, you're going to leave a customer very confused when they try to work out how much they've spent and what their current balance is. The information shown on the statement needs to be complete without any gaps in the numbers of the transaction history. For example, if a transaction is missed, the account total shown at the bottom of the page may not appear to add up. Our rule here is that the statement must be complete with no gaps in the transaction history, account numbers, customer details or financial information for the relevant time period. Moving on to dimension number 3, consistency. This isn't about whether your data is thick or runny. It means that the data should tell the same story in whichever way you're looking at it. If every page on the statement shows the customer their current balance, they need to be the same. If a customer adds their individual transactions together, they should equal the totals shown. The data should also be presented in a consistent manner. For example, amounts and currency symbols should be displayed in the same way. The example shown here has the customer's account number in 2 places, but they're inconsistent. What about a consistency rule then? Wherever equivalent values are shown in multiple places on the statement, they must be equal. Our fourth dimension is called currency. Although we're talking about a bank statement, currency in this sense does not mean pounds, dollars or yen. simply how up to date the data needs to be. If you're expecting that you can see all your transactions up to the end of the previous day, but there's something missing, it means that the currency of the data is not up to scratch. In other words, it isn't up to date enough to meet the required use. A rule that could be driven out of currency is that all transactions up to the end of the previous day should be included. Number 5 in our countdown is precision. Precision refers to how granular the data needs to be. On a bank statement, you would expect financial values to be precise to the nearest 1 pence. If you saw your transactions with 6 decimal places, it would look really strange. And equally, if you saw your balance rounded up to the nearest £500, it would not be very helpful. A rule that could be driven off the precision dimension is data that refers to financial records must be precise to the nearest 1 pence. 6 is a hot topic one, privacy, or the degree to which personal data is protected from unauthorized access, use, or disclosure. You would not expect anyone else to be able to see your information when they log into the bank, and you would not expect your statement to be published on the bank's Facebook page. There are local and global regulations regarding data privacy, such as GDPR, that must be taken into account when thinking about privacy. The rules here are straightforward. Access to the data must comply with all regulations and not be accessible to anybody except those people authorized to see it. You'll probably be glad to know that we're more than halfway through our 11 dimensions now, with the 7th being reasonableness. It sounds like a made-up word, but it is in the dictionary. Reasonableness is all about whether data conforms to expectations and assumptions. The bank might have done some analysis to tell them that the maximum amount any of their customers has in a current account is £10,000. Therefore, if we saw an ending balance of nearly £100 million, as exciting as it would be, it should rightly raise suspicions as to its reasonableness. We could then quite easily put a rule in place that raises a red flag should any balances tip over into unreasonableness in the context of what we would expect to see. We move quickly on to integrity next. This is one of the more tricky ones to define, but it's about how data hangs together as an overall picture. Imagine that the bank stores its customer records in one database table and all the financial information in another table. Integrity is about ensuring that the financial information relates to the right customer. Maybe there's a unique customer ID that ties the two things together. Without integrity, you may end up seeing someone else's transactions, balances, or their home address. A rule that could use integrity is to ensure that all of the information on the statement must be tied together with a customer ID and therefore all be related to that specific customer. Number 9 is timeliness. This one is often confused with currency. Although it's also time related, it's to do with how often or how quickly data can be provided, as opposed to currency, which is how up to date it is. For the bank statement, if there was a 30-day reporting cycle, timeliness rules would ensure that the data was provided in good time to meet that deadline. An easy way to think about the difference between timeliness and currency is this. If the supermarket doesn't have any eggs, that's a timeliness issue. If it has eggs but they're out of date, that's a currency issue. A timeliness rule then might be along the lines of data being available to customers within 1 hour of a transaction taking place. We're nearly through the list now, and our second to last dimension is number 10, uniqueness. Uniqueness is not a prerequisite for all data. For example, many customers may have transactions for £9.99 or have the surname Smith, but for data items such as account numbers, uniqueness checks are a powerful filter. For example, uniqueness of a customer's account number is vital for integrity, consistency, privacy, and accuracy. So we can have a rule that says every customer's account number must be unique. Finally then, the last in the list is number 11, validity. Validity says that the statement should show the correct type of data in the individual fields. Seeing a date in a surname field or the word potato in an account balance is an example of non-valid data. Validity does not ensure it is the right data, however, that's more of an accuracy issue. An example of a validity rule is that transaction dates must not be in the future unless the customer is Doctor Who. So that concludes our whistle-stop tour of data quality. We've looked at what we mean by quality, the ability for something to satisfy a particular need, not necessarily something that is perfect. We then looked into the 11 dimensions of data quality: accuracy, completeness, consistency, currency, precision, privacy, reasonableness, integrity, timeliness, uniqueness, and validity. I've never found a good mnemonic for these, but if you can think of one, please let us know. Crucially, these dimensions help to drive rules that ensure your data quality is fit for purpose and good enough for the job in hand. We hope you've enjoyed this video, and thanks very much for tuning in. Remember to like, subscribe and comment, and if there are any other data topics you'd like to see on the channel, do let us know. That's it for now. See you next time.